So folks, in our last video we developed or we discussed the sum and difference angle identities for sine and cosine. We gave 4 of these, and what we can think of them as giving us is a way of working with the sine of either a sum of expressions, or the cosine of a sum of 2 angles, or the cosine of a difference of 2 angles, and being able to break them down into sine and cosine expressions that don't have the sum inside of the trig expression. And there's lots of reasons in the real world why we might, well, I guess in the real mathematical world, why we might want to do this. But one way to motivate you with this is here we're showing how we can use these sum and difference angle identities to evaluate non-unit circle trig values. So let's go ahead and look at letter B here. And so we've got our sine of 75 degrees. Remember, when we think about the unit circle angles that we gave, we had 15 degrees, or excuse me, 0 degrees, and 30 degrees, and 45 degrees, and 60 degrees, and 90 degrees, and many others. But notice that 75 degrees is... So the sine of 75 degrees, that's not one of our unit circle angle identities. And so what we need to do is we need to come up with a clever way of thinking about the expression, the sine of 75 degrees. So what I'd like you to do is I'd like you to go ahead and pause the video, and I want you to come up with 2 angles whose sum or difference would give us 75 degrees. And those can't be just any angles. You can't do 73 degrees and 2 degrees. They have to be unit circle angle identities. So go ahead and pause the video and rewrite this as a sum or a difference of 2 unit circle angles. So I hope you tried this. There are many correct answers. One commonly given correct answer is to give 30 degrees plus 45 degrees. And we can see that the sum of those 2 angles is indeed our 75 degrees. If you didn't pick these 2 angles, or you have them in a different order, for right now I'll have you go ahead and write them this way, but we'll try this problem another way in just a moment. So let's go ahead and evaluate the sine of 30 degrees plus the sine of 30 degrees plus 45 degrees. Let's go ahead and evaluate that. Well, here's where we need to use these newly developed or newly given identities. And for the sine of the sum of 2 angles, this will be the identity that we use. So we're adding together 2 angles. We'll use this identity here. So this gives me the sine of 30 degrees, cosine of 45 degrees. And then with the sine, notice that's with sine same, this is a plus sign, so we'll have plus the cosine of 30 degrees times the sine of 45 degrees, keeping this matching the way I gave the angle identity to begin with. Great. So the sine of 30 degrees we've now memorized, or we at least can quickly get the answer to that by looking at the corresponding, thank you, by looking at the corresponding right triangle there, where we go out a lot but we only go up a little, so the sine value is a half. And then we can get the cosine of 45 degrees as the square root of 2 over 2 plus the square root of 3 over 2 times root 2 over 2. And we're going to end up with an answer very similar to our previous answer. It won't look exactly the same as we first write it. And there's not a coincidence there. But you also shouldn't try to jump to any conclusions. I would encourage you not to jump to any conclusions about that. I'll just say we've got the square root of 2 plus the square root of 6 all over 4, writing that as a single fraction. Okay, so what I'd like us to do is let's go ahead and do the sine of 75 degrees again, but let's do it another way. So if we go to compute the sine of 75 degrees, I'm going to pick another way to think about this. And the way I'm going to go ahead and think about this is I'll think about this as the sine of 120 degrees, and I will subtract 45 degrees from that. And you can verify that if you do that subtraction, notice that you would get 75 degrees. Okay? Now, what I'm trying to show you is you don't have to do these problems the same way as somebody else as long as you're appropriately applying the identities. So we're now thinking about this as a difference of angles inside of my sine function. So this will be the identity that I use. So we would write this as the sine of 120 degrees times the cosine of 45 degrees. And then sine same, this will be a minus sign here, minus the cosine of 120 degrees times the sine of 45 degrees. So let's see what we end up with. Well, when I go to evaluate the sine of 120 degrees, the sine of 120 degrees, there's that angle 120 degrees right there, and the sine value is the y-coordinate, so we get the square root of 3 over 2, and the cosine of 45 degrees is root 2 over 2, minus, and then if we do the cosine of 120 degrees, well, that would be, careful, that would be minus 1/2. Let me write that as a larger fraction. Minus 1/2 times the sine of 45 degrees, which is root 2 over 2. So it looks like maybe we're going to get something different, but everything cleans up just so, and we end up with the square root of 6 over 4, and then this would be plus, because we've got minus a negative number, so that would be plus the square root of 2 over 4, and we end up at the same location. We end up with the square root of 6 plus the square root of 2 over 4. We get the same value as we did before. Okay. So I'm going to do one more now with you folks. This last one is to look at the cosine of 5 pi over 12. We're going to have some similar numbers in here yet again, and that does happen with these problems. I don't want you to read too much into that. And for the cosine of 5 pi over 12, this one's a little bit harder because it involves reducing fractions in your head and seeing, how could I break up the fraction 5 pi over 12 in such a way that I get unit circle angles. So I'm going to go ahead and do this for you, and then you'll get some practice as well. But one way I could do this is to say that it will be the cosine of 3 pi over 12 plus 2 pi over 12. So notice, first of all, that's a fact. If you were to add these two fractions together, you get back to the original argument that we had before. But it may look like we haven't gotten very far, but aha, if I reduce these down, notice that these are unit circle angles. This reduces down to be pi over 4, and this reduces down to be pi over 6. Let me just double check that. Yes. Okay. So now I've got the cosine of the sum of two angles, and I'll use my cosine angle identity. So folks, you do want to start memorizing these. You will have to have these memorized for the next exam. So you do want to put these on some flashcards and start trying to come up with ways to remember them. But here's my cosine of the sum of two angles, and indeed we used that in a previous example. Okay. Remember that with the cosine value, when this is a plus, this is now a minus, and there are other aspects that make it different from our sine angle identity. So this gives me the cosine of pi over 4 times the cosine of pi over 6. And then with the cosine, this value will, because we're adding these two angles, this value will be a minus sign times the sine of pi over 4 times the sine of pi over 6. And if we go through and evaluate this, we end up with radical 2 over 2 times radical 3 over 2 minus radical 2 over 2 times the sine of pi over 6 is 1/2, and we end up with kind of a familiar answer here, folks. Again, I don't want you to read too much into this other than I'm not making you work too hard to get these answers. But in this case, this simplifies to be the square root of 6 minus the square root of 2 all over 4. Okay. Folks, in this first pre-work, I'm not looking for mastery. We're going to do more with this in class, but what I'd like you to do is to do a little bit more practice just applying and plugging and chugging with these identities. So here you have 3 former test questions. Let me zoom out for you. You have 3 former test questions on the next page. Each one of them has a hyperlinked solution. You'll have to pull up an electronic copy of this if I don't have QR codes for it. And I'll want you to work through these 3 examples here. They're all slightly different than what we're just looking at. And then finally, do make sure that you go and work the associated MyMathLab pre-work. Thank you, folks, for your attention, and I'll see you next time. Bye.